I got so much motherfucking design on right now.
Break it down, bring it back, make it clap. I got 3 old thoughts, new block, where that thing, bitches on my line, and you know.
The topic I will discuss is phenomena of rusting. Rusting is from a chemical aspect referring to the deterioration of a material, usually a metal, due to a chemical reaction with its environment. The most common form of corrosion is the electrochemical, in the presence of an electrolyte, usually moisture or water. The relevance that I can explain in daily life about rusting is infrastructure maintenance. Rusting is a significant concern in infrastructure maintenance, especially for structures made of iron steel, such as bridge, pipelines, buildings. One of the examples of rusting is oxygen, typically present in the atmosphere. Oxygen plays a crucial role in the rusting process. The corrosion reaction often involves the oxidation in the metal, where electrons are transferred from the metal to oxygen.
Next, I will explain about the chemical equation. This corrosion happens when 4 mole of iron, 3 mole oxygen gas plus 6 mole of water will produce 4 mole iron, 3 hydroxide. If one of these reactions is not enough or incomplete, then this rusting will not happen.
While rusting is generally considered a drawback in terms of maintaining the appearance and structure integrity of iron and steel objects, it also has some potential application, benefits and drawbacks. Potential application: corrosion protective coating. Understanding the process of rusting has led to the development of corrosion resistant coating. These coatings are applied to metal surface to protect them from rust and other forms of corrosion. Benefits: rust as a protective layer. In some cases, a thin layer of rust can act as a protective barrier, preventing further corrosion by blocking oxygen and moisture from touching an underlying metal. Okay, for drawbacks: environmental impact. The corrosion process involves the oxidation of iron, and this can have environmental implications, particularly when it occurs on a large scale. The rusting of iron objects can contribute to soil and water pollution. In conclusion, rusting is a natural process of corrosion that occurs when iron and steel are exposed to oxygen and moisture. While it generally considered a drawback due to its negative effect on the appearance and structural integrity of metal objects, there are some potential applications, benefits and drawbacks associated with rusting. That's all for me. Now let us hear from our group member. Thank you.
Hi guys, my name is Natasha Shahira binti Bujang. So my matrix number is RS23273. So in this video, I would like to tell about phenomena ice fluid in water. So it is exhibiting a unique property related to its density and molecular structure. So the key factor at the play here is that ice is less dense than liquid water. The phenomena of ice floating in water has several practical and everyday life implications. So the first thing is drinking water. Why I say like that? Because in cold climates, bodies of water often freeze during winter. The fact that ice float ensures that lakes and rivers freeze from the top and down, allowing aquatic life to survive beneath the ice layer. This is crucial for maintaining ecosystem and ensuring a water supply for both wildlife and the human communities. So in summary, the relevance of ice floating in water extends beyond scientific understanding. It has a practical implication in various aspects of a daily life from ecological balance. Ice float in water, several physical and molecular processes are at play. The key phenomena is related to the structures and density change the water undergoes as it transitions from a liquid to a solid state. So, first thing is hydrogen bonding. Wire-slided water molecules are polar with a positive and negative end. In liquid water, these molecules are in constant motion, forming and breaking hydrogen bonds with neighboring molecules. As water cools, these molecules slow down and begin to arrange themselves in more ordered structures. Next, the density change. Why? The lower density of ice compared to a liquid water is really crucial. Typically, substances become denser as they transition from a liquid to a solid state. However, water is an exception. So, ice is about 90% less dense than liquid water, which is why it floats. The underlying process and mechanism involved during ice floating in water are fascinating and involve principles of molecular structure, hydrogen bonding, and change in density. Let's explore the process in more detail. Polar nature of water molecules. Why? Water molecules are polar, meaning they have a positive and a negative and due to an uneven distribution of electrons. So this polarity gives rise to hydrogen bonding. So the significance of ice floating in water extends across various of scientific, environmental and practical aspects. Here are some key points highlighting it is important. First thing, ecological balance. Why ice floating in water is crucial for the survival of aquatic ecosystem in cold climates. The fact that ice is less dense than water means that it forms on the surface, creating an insulating layer. So, this allows organisms in the liquid water beneath the ice to survive during freezing temperature, contributing to the overall ecological balance of lakes and rivers. This part of video, I would like to tell you all about the chemical equation of this phenomenon. So, this is the chemical equation. So, the phenomena of ice floating in water offers several benefits and plays a crucial role in various aspects of the environment and human activities. So, here are some of the key benefits. So, first is aquatic life survival. The buoyancy of ice allows it to float, forming a protective layer that insulates the water below from extreme cold. So, this is critical for the survival of aquatic life, including fish and other organisms during the winter months. I think that's all from me, so let's hear my friend's phenomena.
Hi, as you can see on the screen, my topic for today is the phenomenon of applying sunscreen. Okay, first, let me introduce myself. My name is Nur Alia binti Jamil Shadi from Faculty of Industrial Science and Technology. My matrix ID is RS23136. Have you ever wondered why we need to apply sunscreen every day? The phenomenon of applying sunscreen involves the chemical process of protecting the skin from the harmful effects of ultraviolet radiation. It is a crucial practice in daily life, especially considering the widespread exposure to sunlight during various activities. Applying sunscreen creates a protective barrier on the skin, preventing and minimizing the penetration of UV radiation. Sunscreen formulation typically contain organic chemical or inorganic mineral compounds. Organic sunscreen absorb UV rays and transform them into harmless heat, while inorganic sunscreen act as a physical barrier, reflecting and scattering the UV rays. These are the chemical equations for organic chemical sunscreen contain avobenzone. Avobenzone absorbs the UV radiation and undergoes a photochemical reaction. When exposed to UV light, avobenzone absorbs the energy and transforms them into different chemical entities, releasing heat in the process. This conversion of UV energy into heat helps to prevent the UV radiation from penetrating the skin and causing damage. Next, this is the chemical equation for inorganic chemical sunscreen contain zinc oxide. Zinc oxides, a common inorganic chemical sunscreen ingredient, act as a physical barrier. When exposed to UV radiation, zinc oxides reflects and scatters the UV rays. The equation indicates the breakdowns of zinc oxides into zinc ions and oxygen, accompanied by the release of heat. This physical barrier prevents the UV radiation from reaching the skin and causing damage. The significance of applying sunscreen lies in its role as a primary defense against skin cancer, premature aging, and sunburn. Consistent and proper application of sunscreen helps mitigate the harmful effects of UV radiation, providing the long-term benefits of skin health. The benefits include reduced skin damage, lower skin cancer risk, and enhanced overall well-being. In conclusion, the application of sunscreen is chemically driven protective measure crucial for safeguarding the skin from UV radiation. That's all from me. Thank you. Bye.